In this video, I am going to explain reaction intermediates. So, reaction intermediates are very short-lived pieces. It appears between a reactant and product. Look at this energy profile. The reactant gets some amount of energy at initially, and the product finally gets less amount of energy than the reactant. So the energy wise, the product is more stable than the reactant, but in between the reactant and product, so there is an intermediate. This intermediate has some amount of high energy, so it is unstable, but it is more stable than these two transition states. So the transition states are higher energy pieces. This is transition state 1 and this is transition state 2. So it is highly unstable, and this transition state undergoes decomposition to form intermediate, and the second transition undergoes decomposition to form the product. So highly unstable pieces are transition state, but somewhat stable pieces is a reactive intermediate. So reactive intermediates are quickly converted into more stable molecules in various ways. There are 4 types of pieces. There is 4 types of intermediates are possible. The first one is carbocation, that is positive charged carbon. That is a trivalent positive charged carbon, and that is called a carbocation. And a free radical, second one is free radical. Free radicals are neutral pieces with odd number of electrons. So third one is carbanion, so negative charged carbon. It's a trivalent negative charged carbon. And fourth one kinds are carbene. Carbenes are the neutral carbon having 2 electrons. So it is carbene. And nitrines, the nitrogen also have 2 unpaired electrons. So let's see carbocation. So carbocations are a trivalent positive charged carbon. Trivalent positive charged carbon. It has sp2 hybridized because carbon has only 3 bond pairs. So 3 bond pairs. So the possible hybridization is sp2 hybridization. So sp2 hybridization leads to planar structure. So all the carbocations except some carbocations, so all are planar structure. It has a bond angle 120 degree bond angle, and due to the positive charge, carbocations are act as electrophiles. So this is carbocation structure, planar carbocation structure. That carbocationic carbon have 1 vacant 2 hybridized 2p orbital, vacant 2p orbital, and 3 bond pairs bonded with 3 substituent, and the carbon have positive charge, so it has a planar structure. So these carbocations are formed by hydrolytic cleavage. So let's see carbanion. So carbanion is trivalent negatively charged carbon. The negatively charged carbon has sp3 hybridization, and sp3 carbon have a pyramidal geometry. So there are 8 electrons in the outermost orbit of the carbanionic carbon. Hence, its octet is complete. It behaves charged nucleophile, and all the 8 electrons are paired. It acts as a diamagnetic species. It is formed by hydrolytic bond fission, like carbocation. It reacts with the electrophiles because carbon have negative charge, so it reacts with the positive charged pieces, that is electrophiles. So this is structure of carbanion. It's a pyramidal structure like ammonia. The lone pair of electron present in one of the sp3 hybridized orbital. So remaining 3 are bond pair, 3 bond pair plus 1 lone pair. So it leads to sp3 hybridization. Let's see free radical. Free radicals are neutral pieces with unpaired electrons. So highly unstable. It combined with another free radical or react with another pieces. So the free radicals are sp2 hybridized. Some free radicals are sp3 hybridized carbon. So it has half-filled 2p orbital. That 2p orbital has 1 electron and carbon attached with 3 other substituents. Totally 3 bond pairs, 1 unpaired electron, or 7 electron pieces. So some characteristics of free radicals. Carbon radicals have 7 valence electrons, 3 bond pair, 1 unpaired electron. So radicals are paramagnetics since the presence of unpaired electron. So all the radicals are paramagnetic in nature. So can be observed by electron spin resonance ESR spectroscopy. So radicals are identified by using electron spin resonance ESR spectroscopy. And the radicals are often uncharged neutral pieces. There is no positive or negative charge on the radical, so it is a neutral species. But some radical ions are charged. That may be radical cation. The radical cation has positive charge, and radical anion has negative charge. But so these radicals, trifluoromethyl radical, which is a pyramidal in shape, but the methyl radical is planar in geometry. The planar radicals are sp2 hybridized and the pyramidal radicals are sp3 hybridized. A simple alkyl radical, it's a proper planar structure, and the free radical, which the carbon is connected to high electronegative atoms, that proper pyramidal geometry. Cyclopropyl radical also pyramidal radicals. Generation of carbocations. Carbocations are generated by hydrolytic fission of carbon hydroatom bond. So in this reaction, the carbon bonded with the chlorine atom. The chlorine and the carbon having different electronegativities, so it is a polar bond. The chlorine is more electronegative atom. It take bond pair electron and get out as chlorine minus. Therefore, carbon get positive charged carbocation. And then the second reaction, protonation of alcohol followed by dehydration. During the protonation, hydroxyl group of the alcohol bonded with H plus to form OH2 plus. This OH2 plus is highly unstable due to having positive charge on the oxygen atom. So it is a better leaving group, and this OH2 group is eliminated and carbon get positive charge. This is one of the way to convert alcohols into carbocations. So the alcohols first made into protonation. The protonated alcohols are highly unstable. So the water molecules are removed after protonation. Then protonation of unsaturated systems. The proton is added one of the carbon atom of the unsaturated system. And there is one of the double bond goes to bond form with the H plus, and one carbon get positive charge. So this addition is based on Markovnikov rule. This H plus is added which carbon atom having more hydrogen atom, and this carbon is formed carbocation. It is secondary carbocations. It leads to more stable carbocations. If hydrogen atoms added to this one carbon, this leads to the formation of primary carbocation, and it's highly unstable. So that carbocation is not formed. So protons are added, one of the double bond carbon, one carbon get positive charge. So we get carbocation. Then another reaction, action of superacids on alkyl fluorides. So it's alkyl fluoride. So antimony pentafluoride with the fluorosulfonic acid. So antimony pentafluoride combined with the fluorosulfonic acid is called a superacids. So these superacids, the fluorine atoms from alkyl fluoride is attracted by antimony pentafluoride and converted into hexafluoride. So the carbon get positive charge. So then deamination of primary aliphatic amines by nitrous acid. This is primary amine, and HNO2 is nitrous acid. So it's converted into diazonium group. The diazonium group N2 plus is a better leaving group. Now this N2 plus is easily removed from the alkyl group. So alkyl group get positive charge. So we get carbocation. So in this manner, carbocations are generated. So let's see the generation of carbanion. So carbanions are generated hydrolytic fission of the carbon bonded with another atom. So in the first case, a group attached to carbon leaves without its electron pair. So in this case, it's a proton. If protons get out without its electron pair, so that electron pair goes to the alkyl group, that is carbon atom. So carbon atoms acquire negative charge, so it is a carbanion. Actually in this reaction, a base is required. A base is required to remove H plus. So base remove H plus. So while removing H plus, the bonded electron goes to alkyl carbon. So that form negative charged species, that is called carbanion. And this is simple acid base reaction. Acid base required, and base is required to remove protons. So another leaving group also form carbanions in this reaction. Carbon dioxide is removed, that is a decarboxylation. This is carboxylate ion, and that O minus, the negative charge goes to here, and this bond goes to alkyl group, and this is eliminated as CO2. Then carbanion is formed. So another way of formation of carbanions as addition of Y minus. This is a nucleophile. So addition of nucleophile, one of the double bonded carbon. This nucleophile having a pair of electron. This pair of electron is to make a bond with this carbon, and one of the 5 bond goes to the nearby carbon atom. So that carbon atom get negative charge. So this is one of the way to form carbanion. The most common reactions of carbanion. So after formation of carbanion, it's highly unstable. That carbanion combined with the positive charged pieces, so it produces a neutral compound. So then this is an nucleophilic substitution type reaction. R minus is a nucleophile. It goes to it's go to bonded with the carbon, which has the leaving group. This leaving group is eliminated as X minus. So now a nucleophilic substituted product is formed. So here this nucleophile is R minus, and this carbon is nucleophilic carbon. So then another one important reaction is the negative charged piece is carbanion. This nucleophile go to bonded with the C double bond O carbon. In case of C double bond O, so carbon have delta plus and oxygen have delta minus. So always carbon react with the negative charged pieces. So whatever the negative charge pieces, it approaches the carbonyl carbon. So negative charged carbanion, this carbanion approach the carbonyl carbon, and the C double bond, one of the double bond goes to the oxygen atom. That oxygen atom get negative charge. So this is one of the electrophilic substitution, nucleophilic substitution reaction in aliphatic trigonal carbon. This is trigonal carbon, carbonyl carbon. So this follows a tetrahedral mechanism. So these are the reactions of carbanions. The carbanions undergoes react with the positive charged pieces, and another one reaction nucleophilic substitution. Then nucleophilic substitution with the carbonyl compounds. So these are reactions of carbanions. Then generation of free radicals. So free radicals are generated by homolytic cleavages. That is a bond pair electron is sharing by two atoms. The two electrons are taken by each one atoms. So there are two ways. The first way is thermal cleavage. Any substance subjection of any organic molecule to high enough temperature in gas phase result the formation of free radical. The molecule contains bond dissociation energies. Bond dissociation energy about 22 or 40 kilocalorie per mole. That is equal to 80 to 170 kilojoule per mole. This cleavage can be caused by liquid phase. Thermal cleavages takes place in liquid phase, and there are main two examples on cleavage of diacyl peroxide. That diacyl peroxides are converted into acyl radical. That acyl radical decomposed into form alkyl radical. So another one cleavage of azo compounds. That azo compounds converted into alkyl radicals by thermolytic cleavage. Then photochemical cleavages. That photochemical radiation, light radiation having 600 to 300 nanometer wavelength, that have energy 48 to 96 kilocalorie per mole, that is equal to 200 to 400 kilojoule mole, which is of the order of magnitude of covalent bond energies. So when supplying this much energy to the substance, that substance undergoes photolytic cleavage uh, that leads to formation of free radical. So these are the main reactions for the formation of free radical. The first one reaction is said diacyl peroxide. So this is diacyl peroxide and this is peroxide linkage. So peroxide, it's look like if you take hydrogen peroxide is H2O2. So in the place of hydrogen, there are two acyl groups. So it is called a diacyl peroxide. So peroxide linkages are highly unstable. It undergoes homolytic fission during the heating the substance. So one of the bonded electron goes to one oxygen atom, another electron goes to another oxygen atom. This leads to carboxylate radical. So after formation of this carboxylate radical, and this carboxylate radical is the carbon dioxide is molecule is eliminated, then alkyl radical is formed. The, the radical electron goes to form bond with the carbon atom, and another electron coming from CR bond, it forms C double bond O. C double bond O, CO2 is eliminated and alkyl radical is produced. Then another one azo compound undergoes thermolysis. So during the thermolysis, the N2 group is eliminated. That is one of the electron goes to form a nitrogen radical, another electron goes to form nitrogen radical. The two radical combined with one new pi bond, that is N double bond N converted into N triple bond N, that is eliminated as N2. So the radical is formed. So another one of the photochemical reaction, the chlorine undergoes photolysis. It produces chlorine radical, and ketones are highly sensitive with light in vapor phase that produce acyl radical. So after formation of acyl radical, the carbon monoxide is eliminated. It leads to formation of another alkyl radical. So this is the way to form free radicals. So another generation of carbenes. So carbenes are divalent pieces. Divalent neutral pieces. So mainly carbenes are formed in alpha elimination. So both hydrogen and leaving groups are eliminated from same carbon atom. That is called alpha elimination. So in this alkyl chloride, first H plus is removed, it forms carbanium. Then another chlorine is removed, so it leads to formation of carbenes, dialkyl carbenes. So another way, the trichloroacetaldehyde undergoes decarboxylation on heating, so that eliminate carbon dioxide and Cl minus and produce dichlorocarbon. So which is electrophile. So dichlorocarbon is a good electrophile in Riemann-Tiemann reaction. So another, it's a cyclopropyl ring as tertiary butyl group. It's a highly strained ring. So it undergoes photolysis. and that produce the carbanion, and these two bonds undergoes this one bond and this one bond. This two bond undergoes homolytic cleavage. So here one electron goes to this carbon, and here one electron go to this carbon. Another two electrons make a new 5 bond. So it leads to formation of its carbene. So another carbon bonded with heteroatom. This heteroatom is removed, and that lead to formation of carbenes. R3 is not correct. R2C 2 electrons. This is carbene. So these are the ways of formation of intermediates. So thanks for watching. Thank you.